Hello, welcome to Routing Service with Real-World Severe Weather. This is our demo paper. I'm Sarah George with Iru Lee, Craig Afflebeck, Muhammad Ali, Abdul Tawab Hendawi, David Hazel, and Kurdera Desai, with help of University of Washington Tacoma. This is our project. Our problem: a tornado is coming. How do we escape from it, especially if we're in a car? One of the most dangerous places to be during a tornado. To find this safe route away, we need information. The tornado watch warning, traffic, any road closures, shelter locations, and of course, our present location. How do we calculate all this data real time? Our solution: the iTornado app. This app and demo was created using C#, SQL Spatial Database, and Worldwide Telescope. The iTornado server collects relevant real-time data, like the tornado watch and warning data from the National Weather Service, traffic, any road closures, any shelter locations, and of course, our present location. The server calculates a safe route to a shelter, and it avoids the tornado. The server can also calculate a safe route through a tornado outbreak and away from all the tornadoes. The iTornado mobile app directs you to the safe route using both a visual map on your screen and by voicing the directions like a GPS. The modified A* algorithm is what our server uses to create the routes. First modified version is the avoid tornado, and this one we use intersect to determine if a child node of the start node intersects in any way with the polygon that is the tornado. If it does intersect, we remove it completely from the calculation. If it does not, it gets placed in a queue. Once the queue is full, we do as a traditional A* algorithm and calculate the cost of the route to the endpoint, the destination. The route with the least cost is the route that is chosen, and once we reach the destination, the algorithm is at an end. The second version of the modified A* algorithm is created for drive away, which, after we have removed all of the child nodes that intersect with the tornado, we fill the priority queue in a greedy fashion, choosing instead to fill it first with the child node that is the longest minimum distance away from every tornado polygon. This algorithm ends when the minimum distance between the child node and actually all of the tornadoes, it exceeds a threshold we give it, for example, 50 or 100 miles. The last variation for modified A* algorithm is go to safest shelter, which basically does the same thing as both avoid tornado and drive away, but also has the additional complication of having to check not only the location of your destination, but whether that location is currently or will be in danger from a tornado. Now, for the demo. This is Microsoft's Worldwide Telescope, and for this demo we used historical tornado data from a tornado outbreak back in 2004 that spawned more than 100 tornadoes in an 8-hour period. We will be concentrating on a F4 tornado that traveled in this path in a few hour period. These two polygons represent the polygons that the tornado traveled in and during this outbreak. This white line here and this white line here are examples of avoiding the tornado using these two tornado polygons. This red line here and this red line here are examples of drive-away routes using, of course, both of these two tornado polygons. These 5 blue push pins are our example shelters. So, on with the demo. Now that we have some colored dots on here, I will zoom in so that things become a little clearer. Now, this white dot here is our F4 tornado. These yellow dots and this red dot are cars. This car dot is red because it is in this polygon that for the demo we have designated as a danger zone to exhibit just how accurate our system can be. Yellow represents that they're not as in danger as the red. This purple line that's showing up behind the tornado is the tornado's damage path, a path that is completely impassable, at least according to our system, because some tornadoes will actually destroy roads, not just lift up houses or destroy roofs. This, of course, blue line right here is an example route from this car to this shelter as a drive to shelter example. And this car would not, of course, go to any of the other shelters because in doing so it would cross the tornado's path or go into danger. And it would be, of course, much a longer route. You will notice that this polygon is smaller than the other one, as the National Weather Service has zoomed in on its predictions, made them much clearer. And the predictions come to us 10 seconds after the National Weather Service makes it. This car, as you notice, just turned yellow, and that is to show that as soon as a car exits the danger zone, we can tell that it is no longer in danger, and thus becomes yellow. Thank you for watching our demonstration. We hope you enjoyed.